Good morning. Hello, viewers. I welcome you all to the Mathematics Olympiad preparatory class. So, by Mathematics Olympiad class or by Mathematics Olympiad itself, we mean advanced mathematics. And an aspect of advanced mathematics that is not too difficult for secondary school students to cope with. But at the same time, every content of these of this mathematics is not the same as all we have in secondary school mathematics, be it in the core mathematics or the further mathematics, because it contains 4 areas of mathematics. So one of the areas is the algebra. The other area we have there is geometry. The other area we have is number theory, and the last one there is the combinatorics. So in each of these aspects, so 2 of it depends on algebra, meaning that what? The knowledge of algebra, how to do some manipulations or carry out some manipulations which we are going to learn in algebra will as well be useful when it comes to the number theory as well as when it comes to what the combinatoric aspect of this curriculum of this mathematics which we are trying to prepare for. And as a result of this, so I will love it that what we begin with the algebra. And by this algebra which we are also talking about here is advanced compared to what we have in secondary school. So the extent that if anyone is not thoroughly trained to know how question is being addressed, how question is to be solved in this aspect of mathematics, so one will not be able to do what? To solve a single question. So the reason why we have to do what? To organize this short video classes. So today we are beginning with the algebra. And before we also move into this algebra, there are some basic things that one needs to familiarize himself with, so that dealing with those topics as we have it under the algebra will become very easy to understand. So the aspect of those foundations that I'm going to talk about today is the one which talked about expansion, right? So the one that has to do with expansion. So we all know very well that in our basic mathematics, so we can be asked to do this expansion, x plus 1 squared. And we know the easiest way to carry out this expansion is simply to say x plus 1 multiplied by x plus 1. So, and we know the rest is we ensure we open this bracket so as to be able to obtain the result. So, but what if I am posed with situation of x plus 1 raised to power 5 or some power higher than this 5? So, am I also still going to repeat the same process of saying x plus 1, x plus 1, x plus 1, x plus 1, and x plus 1. So we can see that doing it this way is going to be what? A perfect waste of time. So as a result of that, so it will be important we learn what is known as binomial theorem, or what is known as the Pascal Triangle. But I prefer to use that Pascal Triangle because it is straightforward and it's will not contain some formula. Because if I will have to go by the other approach, which I call the binomial expansion, so that one also requires the knowledge of permutation and combination, so which I believed most students in this very class have not been exposed to it. So as a result, I will love going by the Pascal Triangle, right? So remember what I've said so far is we want to first of all deal with expansion. We want to deal with expansion. So in the basic secondary school syllabus, we were taught how to do this expansion. So we can see if it is power of 2. So we as well can write this thing as x plus 1 multiplied by x plus 1. We try and open the bracket and we can come up with the result. But what if we have question that looks like this, that is x plus 1 raised to power 5, when the power is higher. So do we also continue with this approach? So it will become it will look somehow, and it will look stressful if we want to apply this approach by expressing x plus 1 raised to power 5 in 5 places. And I as well said that, what if this power is up to 10? So do we also repeat this same thing 10 times? So after we've done that 10 times, so we'll now be opening the bracket one by one till we get the result. So we can see that one is a complete waste of time. So in order to remove those stress, so it is important we learn either the Pascal triangle or the binomial theorem. But Pascal triangle will be straightforward regarding the requirement of the syllabus which we want to cover. So as a result, so we are quickly going to talk about the Pascal triangle. So we should know that one thing led us into Pascal triangle. So what led us into that is we have to open to express or to simply simplify what we have here. So in the process of simplifying this thing, then it will be important to make use of what is called Pascal triangle to enable us to express this thing or to simplify this thing without wasting much time. So I will quickly do that now. In fact, I will apply it to this one as well as this one. But what is that Pascal triangle? So let's try and see how it is formed first. So the word begins with Pascal triangle. So Pascal triangle is a means by which we can carry out a multiple expansion. So we use it for powering objects, for multiplying objects. The time of its appearance is from 3 upward. We also can use it for 2. But what is the Pascal triangle? So Pascal triangle begins with this pattern. The first pattern is we have 1 here in the first line. So in the second line, we have one to the left of this 1, and we have another 1 to its right. So this is the basis of Pascal triangle, right? So we can use this one to generate as many lines as possible. So in order to form the next line, what we do is this very one we have here, I will take it to the left like this. And this very one, this last one I have here, I will also do what? I will move it to the other side. So remember, you can see what I've done. The one here, I extended it here, while the one here, I have it here, right? And now, this one and this one that we now have in the middle here, you can see this and this, all right, happens to be in the middle of these two. So we are going to combine this. So here I'm going to say 1 plus 1. Process of doing this combination is by addition. So we combine by adding. So here I will say 1 plus 1, that is 2. So that gives me 2. Now my 2 has to be written in between this and this in this line. So meaning that what? My 2 is going to be here. Right? So don't worry, I will still tell you much about what do we use this 1, 2, 1 for. So we are going to know how it is used. But what we are dealing with presently is how do we form a Pascal triangle. Now, we also can continue. Let's move to the next line. So to forming the next one, what do I do? This very one here, I will repeat it here. Right? That is, I will take it to the left of this one here. Why the one I have? That is my the one I have at the extreme sides of this line. So this one, I will take it to this side. Why this one will also be extended a little bit beyond the level where it is in the next line. Right? I haven't done that. So I will combine this and this. I will combine this and this. So the result of combining 1 and 2 will be in between 1 and 2 in this next line. And the result of combining these 2 and 1 will also be in between these 2 and 1 in this line which we are dealing with. So that would be 1 plus 2 here gives what? 3. And 2 plus 1 here gives 3. So meaning that what? We formed the Pascal triangle up to this level. I can continue to infinity. So let's try one more. So in order to form the next one, that is in the next line, what will I do? the initial one, the extreme one I have here, I will move it here, right? While the last one which I have here will also be moved here. I hope we are following. So this one here, those two extremes one, we are going to place one beyond the level where we have this one, and this one also beyond the level where this one is existing. So the rest is we are going to combine this and this. I'm going to combine this and this. I'm going to combine this and this, right? So what I have here is 1 and 3, but we know the means combining this any two numbers there is going to be by addition. So here I will say 1 plus 3. We know that gives what? 4. So 4 will be written in between these two numbers that generated it. So meaning that I will have 4 here. And also I have 3 and 3. So I will say 3 plus 3. That one is 6. So that 6 will also be placed in the next line in between where? In between these two numbers that form this 6. We also see that this and this can also be joined. So 3 plus 1 here gives what? That one gives 4. So that 4 will be in between this 3 and 1 in this new line. So meaning that what? My 4 will be here. So if we love to do what? To continue doing it, we can use this thing as a form of game. We can play with it. So one of the beauty of this thing is let's try it as many lines as possible as we can do. But the essence of doing it in this class is only for us to be able to know how it is done. So, and I believe with this little one which I have done, so we are good to go. Right. How do we now apply this thing? All right, so let's have a sample question so as to be able to do that. Now, suppose I'm asked to expand x plus 1 raised to power 2. I will begin with the power of 2. So to doing this, the very first thing I will have to do is this. We have two numbers within this bracket, right? So we are going to begin by saying that this x has the power of 2, while this other number has the power of 0. So that's the idea behind the application of this thing, right? Let me say the idea behind the expansion of this thing. Expanding this thing means I want to begin by saying that this power belongs to this first item within the bracket, while the second item I have within the bracket do not have any power. So it does not have any power here. We will translate that one to mean that it has the power of 0. So I will repeat that one one more time, then we are going to get the results. So remember, to expanding this thing, so what should be our reasoning? Our reasoning should be that these two, right, this power of 2 belongs to only x, and this second number here, 1, which I have in this bracket, do not have any power. And I will continue until this one will not have any power, and this one will also have the power of 2. That is, I will do it in increasing order like that. So though it will be increasing order for one of these two elements, while it will be decreasing order for the other one. So to begin with that, so I'm going to write this one. The first item I have in this bracket, I will say raised to power 2. This is not whereby I'm dealing with raised to power 4. So it means this first one, I will write it as the power of 4. While the other number I have here, I will write it having power of 0. That is, it does not have any power. So the best way to do that is combining this and this when we are expanding now. So I can say multiply by 1 raised to power 0. That is the first case, right? And this process, what I just did here, will continue until this first one has the power of 0 and this second one has the power of 2. So to do the next one, I will say plus, right? So plus what? It is these two item ones again. So remember that we are moving to a point whereby power of this x becomes 0. So since I'm trying to reduce the power of this x, so meaning that if this one has the power of 2 now, if I want to write the next one, the power will be what? Will be 1. So I want to reduce it, right? I want to reduce it until it has the power of what? 0. Why the opposite happened to this? So remember, when one power, when this one reduces, its power reduces, it means this one will gain. So what will happen here is I will write this one as x raised to power 1, right? Then to combine the other one with it will be multiplied by 1 raised to power 1 now. So try and understand the principle involved. So in this aspect of mathematics that we are going into, so it is not the use of formula, but only to understand what is going on. So once we understand what is going on, we should be able to solve any question, right? So, and the idea behind this expansion, behind it is that we begin at every point in time. We want to combine these two items, these two elements inside this bracket, right? So initially, the first one we have the whole power here, while the second one will not have any power. So that was why we wrote it this way. So when we progress, the power we have for this one will be reducing it gradually, and at the same time this one will be gaining those things that this one is losing. But the stopping point of what we want to do here is a case when this one that has the highest power, the whole power of 2 now, has no power again. So meaning that in the second step, I will say x raised to power 1. So we have taken one of the power, right? And the power we took from this one, we will give to this one. So we can see this one is 0 before. And we took one from where and give it to the one having 0, it will now have the power of what? 1. Then we are going to continue. So remember I said we'll continue until this first item do not have any power again, meaning that what? We remove this power again by 1. At every point in time, we'll be reducing such power by what? By 1. So that is the rule by which this expansion work. So the next one will be what? X raised to power 0 multiplied by 1 raised to power 2. So once I reached a point whereby this second one now has the maximum power and the first one do not contain any power again, or it has the power of 0, that is where we are going to stop, right? Now, we are not done yet with what we have done here. Now, after this one now comes the application of the Pascal triangle, right? Now, it now depends on what exactly are we expanding. To what power is the expression given to us? Is it power of 2? Is it power of 1? Is it power of 3 or more? Right? Now, if an expression involves power of 0, so that means we'll be interested in what? In the first line. So this first line is used when we have the power of what? Of 0. That is, if the expression given to me contains power of 0, right? That is even one of the reasons why we usually say that what? Anything raised by 0 is equal to 1. We can also see Pascal triangle as answer for that. You know, most people usually ask, why is it 1? Most responses from teacher is because anything raised by 0 is 1, and Pascal triangle partially as what? Has answered that. Now, if the expression given to me contains the power of what? Of 1, so it means I'm only interested in second line of this Pascal triangle. So remember, when there is a need for us to apply this Pascal triangle, we are not interested in this full construction, right? So we should just go straight to the point. So what is the power of the expression given to me? So it is power of expression that will tell me where do I have to stop when computing this, right? So if the expression given to me has the power of 1, then it means I only need this. So every other thing is what? Is not necessary. Also, if the expression given to me has the power of 2, then, so okay, let me also put this one. So I can say we use this one when the given expression has the power of what? Power of 1. Also, when the expression given to me has the power of 2, so that means this will be used, right? So that is when the expression contains what? The power of what? Of 2. That is, if that expression, the whole thing inside the bracket is raised to what? To 2. And we can see the expression which we have here has what? 2 as its power. So in that case, so this is what is important to us as far as this question is concerned, right? Now, these numbers we have here will now become the coefficient for each of what we have done here. So in that case, we are going to open a bracket. So you can see this is the first expansion. This is the second expansion. This is the third expansion. So meaning that we are dealing with power of 2. I'm interested in this line, right? So since I'm interested in this line, it means so the first expansion here, the first number I have here will be written here. So that number will be the coefficient of my first expansion. So second expansion is this. So it goes with what? The second number here. So let me adjust and put my 2 here. And the last one is 1. So this is the last one. So we're also going to put 1 here. So the rest is just to combine everything and get the result. So this one becomes 1 into s squared multiplied by, remember from basic laws of indices, anything raised by 0 is what? Is 1. Plus 2 into anything raised to power 1 is that thing itself, times anything raised to power 1 is that thing itself, plus 1 into, so you can see x raised to power 0, anything raised to power 0 is 1. That is 1 plus 1 raised to power 2, meaning we repeat 1 twice by multiplying 1 times 1. You can see that gives what? 1. Right? Now, what's the next thing? So I will write it as 1 into s squared times 1, that is s squared, plus 2 into x times 1, x, plus 1 into 1 times 1, we have 1 here. So we can round up with the answer now. So 1 times s squared gives s squared, 2 times x here gives 2x, and 1 times 1 gives 1. And this is the expansion of s plus 1 raised to power 2. We also can approach it traditionally by saying s plus 1 bracket s plus 1. When we multiply everything out, that is, we apply our distributive property, so we are still going to come up with this very result. So we quickly take a few minutes to copy this and we shall continue. All right, let's also try this one. Expand x plus 3 raised to power 3. But we want to use the Pascal triangle to dealing with this. So, and before we, now since we are using the Pascal triangle, it is important we know what level of that triangle is important. So we easily can form that one here. Let me say 1, 1, 1. We know this is the basis. So this is line 0, line 1. So I need power of 3. So I'm going to I will construct line 2, line 3. So but I only need that of line 3. So this is line 0, line 1. So let's say it is power of 2. So it will be 1, 1 plus 1, 2, 1. So I'm in line 2. This one has the power of 3. It means I have to go to what? To the one representing 3. Right? So I will write my 1 here. I write my 1 here. 1 plus 2 here gives 3. 2 plus 1 here, 3. Then this 1. So meaning this is the important item I need as far as Pascal triangle is concerned. So I even can rub the rest. And when it gets to a time, we don't need to compute this thing again. We naturally know that, okay, raised to power 3, the coefficient should be 1, 3, 3, 1. But pending that time, whenever we have cause to do or to carry out expansion like this, it's important we quickly compute the Pascal triangle and we read. The first one is for 0, second one is for 1, third one is for 2, fourth one is for 3. So everything we have in the third line, we are going to copy it outside. So, and that's what we will use for this expansion. All right, so I will now write my solution is s plus 3 raised to power 3 becomes right? So remember I said we should expand first before we are going to apply this thing. So by Pascal triangle, we know this thing I want to do here, we have 4 different expansion. We always begin when this one take all the power and it gives nothing to this one. We progress like that in increasing order, until it contains no power. So in that case, this will be written as x raised to the power 3 multiplied by what? 3 raised to the power 0. So the next one will be what? The power will reduce now. From 3 now, it will drop to what? To 2. That becomes x raised to the power 2 multiplied by 3. So the one that, this one dropped 1. So that one, this one will gain it. So it will be multiplied by 3 raised to the power 1. The next one will be what? So to also drop another power. So that is reduced now from 2 to what? To 1. So that one will be x raised to the power 1 multiplied by 3 raised to the power 2. Remember I said this process continues until this one has the power of what? Of 0. So that is plus x now raised to the power 0 multiplied by 3 raised to the power 3. So once we are able to do what? To get to this point whereby this x contains no power and this second one occupies the whole power, that is the stopping point for the expansion. Right now, but we are not done yet with the expansion which we have here. One more item is needed, and the item is the coefficient of all of these things. And where do we get that coefficient? Pascal triangle will provide us with that coefficient. That is just the only contribution of Pascal triangle as far as this expansion is concerned, right? So we can see the first one here is 1. It means I will say 1 into this. Second one is 3, so that will be 3 into this. Next one is 3, that will be 3 into this. Last one is 1, so it will be 1 into this. So after this, I can say that we are partially done, and the rest is we manipulate and get the result. So we say 1 into x raised to the power 3 times 1. So times 1. So remember, anything raised to the power 0 gives what? 1. Plus 3 into x squared multiplied by 3. So we can see anything raised to the power 1 will give us that in itself. Then plus 3 into x raised to the power 1 means x, that is anything raised to the power 1 gives that in itself. Multiplied by 3 squared here is what? 9. Then plus 1 into x raised to the power 0 here is 1 multiplied by 27. So that becomes 1 into x cubed plus 3 into 3x squared plus 3 into 9x plus 1 into 27. So to round up with this, we are going to say that 1 times this gives x cubed plus 9x squared plus 27x plus what? Plus 27. And this is the expansion of what? X plus 3 raised to power 3. So in order to make what we are doing here to look lively, so at the initial stage like this, we are not going to overburden ourselves with too much work. So little work, plenty of exercising. So this is where we are going to call it a day today, right? But shortly, okay, not even here. So in the main platform where we are going to be checking our videos as well as to submit the assignment, more of the assignment we are supposed to go over is going to be posted there. So remember, this is Olympiad, and Olympiad mathematics, it encourages excellence, and the only way to achieve that excellence is what we are going to practice. So anyone who is not ready to practice, anyone who is not ready to take much time solving problems, embracing problems, dealing with problems. So remember, the more problem one is exposed to, the more sound is it going to be, is he or she going to be in things that has to do with such problems. So as a result, we need to do what? To embrace problem we solve. I mean mathematical problem. I didn't mean problem in the reality or in the real sense of it. So let's try and understand this thing. And also, Understanding of the principle is what counts as far as Olympiad is concerned. That's one of the difference between the Olympiad mathematics and our normal secondary school mathematics. So as a result, let's try and understand the principle involved in um, everything which we have done. So, and also we've not started dealing with Olympiad work yet, but we're only trying to lay foundation on things that will make solving questions, dealing with problem to what to be easy. So we are still taking the key. So once we are presented with the key, then we can go ahead to what exploring those Olympiad mathematics topic one by one. But pending that time, let's just be focused. Let's go through this thing. So it's whereby when we check this and watch this thing, it is not still clear. So you are free to call me, chat up with me and rest so that I can re-explain. So my essence is your understanding is my own interest. So once you understood it, so then that is the only way by which I will be satisfied that I have taught you. Otherwise, I've also wasted my time. So without talking too much, we are going to call it a day here. Thanks for watching.